And welcome to the Industry 4 Community Podcast, hosted by yours truly, Walker D. Reynolds. Today we have a very good podcast for you. This is one I've actually been waiting for. We have a long list, 6 or 7 that we've got to film this month, but this one directly came out of a Discord discussion on artificial intelligence and machine learning, which obviously is hot button topic. It's the topic du jour today, in not just in industry, but I think all across, consumer and commercial applications. Our guest today is Jordan Reynolds, who is the Vice President of Artificial Intelligence and Autonomy with Rockwell Automation. You may know the bulk of Jordan's experience in our industry was with Calypso. If you have any familiarity with Calypso by Rockwell, then that was Jordan's purview there. But Jordan joined a conversation with John Maldonado, Rick Bellotta, and some others in the Discord server on AI. It was a fascinating conversation. Jordan came in kind of at the end and explained a little bit better about, hey, here's kind of where industry is going with AI, and specifically, here's some of the tools that are being used on the commercial side that I think are really benefiting people. And we reached out to Jordan and said, hey, would you be interested in coming on the podcast? And he accepted. So today we're going to talk about FOSS, AI, and ML options. We're going to be talking about commercial options. We're talking about what Rockwell's doing. And we'll just kind of go wherever the conversation goes. So with that, Jordan, thank you for joining us. Anything else I missed? Anything else you want the audience to know about you before we get started, other than the fact that you're in Austin, right? You're down in Austin, Texas.
Yep, I'm in Austin, Texas. I've been here for about 8 years. I was born and raised in Seattle before that. You covered it. I've been at Rockwell since 2020. Calypso was acquired by Rockwell right in the beginning of COVID. At Calypso, Calypso is a system integration company that focuses on digital transformation. We're now pretty much exclusively focused on the manufacturing and automation space. And that's how I got into Rockwell. And I've since moved into a new role where I have sort of corporate responsibilities for our artificial intelligence initiatives and our kind of evolution from automation to autonomy.
All right, perfect. So in that autonomy piece, I think one of the things that the audience is really going to learn in this conversation today is that the place that machine learning and artificial intelligence is being used the most in industry at this moment, right now, is not the place they think it's being used.
Mm-hmm.
Autonomous vehicles are really where, if you're going to see the bulk of where ML and AI is being used, there's so much being used in autonomous vehicles, so specifically, in material handling. That's probably, where I see it, I think the audience would be really surprised that that's really the place where the play is right now.
Yeah.
Even though everyone's talking about generative AI and ChatGPT and all those kind of things, really the play is right now in automating, making material handling autonomous. Not just that piece, but that's a huge focus, is making material handling autonomous.
Yeah. I completely agree, and I'm glad you see it that way as well. And I don't think that's very well recognized, because the majority of the consumer applications of AI today are based on large language models, transformer architectures, things like ChatGPT for creative generation and information retrieval. But some of the most compelling and technologically advanced applications of AI are in things like control systems and automation frameworks, and autonomous vehicles, autonomous mobile robots, et cetera, right? So that should be more well known than it is today, I think.
It's funny. I did a consulting. I consult for M&A, so there's an agency that hires me to consult on mergers and acquisitions. And maybe 6 months ago or so, I did a consulting call on this very topic, right? So they were like, "Hey, we want to talk about AGVs, and we want, where do you see the play is there?" And I said, honestly, I think it's going to be the fastest growing sector of our market, like that. And the reason why is because I think the level of effort to implement ML and AI is the lowest in that area.
Yep.
That it's the place where you're going to get the biggest bang for your buck.
Mm-hmm.
And the the analysts that I was advising for were really shocked that that was my position. I said, well, I don't talk about it all the time, but at the end of the day, the truth is that all of the variables, the data is too messy in many other places for us to really, the industry isn't mature enough, doesn't have clean enough data yet.
Mm-hmm.
But when it comes to material handling, if you were to go ahead and just put a GPS tracking device on a forklift, for example, and watch a forklift path throughout a plant in a day, you would be stunned at how they take the exact same path over and over and over and over and over again, and how clean that data is. And if you can train off of that to automate so many of those functions. And so it just makes sense to me that, hey, AGVs is kind of where it's at. But with that, let me go through what this conversation was. I'll quickly just go through it, and then we'll get into the larger discussion about AI in industry and kind of where you see it. Okay.
Sure.
So John Maldonado, I think this was in the AI or ML channel on the Discord server, said he started by asking for impressions on Rockwell's AI products, specifically FactoryTalk Analytics Logix AI, which aims to predict anomalies in production processes using machine learning. Rick Bellotta comes in and says, hey, there's some limitations in the Rockwell suite, emphasizing a preference for solutions like TwinThread. Those of you that aren't familiar with TwinThread, I think Rick is an investor in TwinThread, and so he's talking about TwinThread all the time. TwinThread is a great solution. I actually think it's a weird comparison to try to compare the Rockwell suite with TwinThread, but I understand where Rick was coming from. But he pointed out some limitations that he saw, or at least he believes are in the Rockwell suite, and he promoted TwinThread that learn from historical data and discover causal relationships independently. I think where your real contribution comes in right after this. Rick's discussion highlighted concerns about whether Rockwell's AI trains on user data or relies on generic models, with a consensus that machine-specific models are necessary for effective predictions. I'm going to ask you specifically about that here later. Maldonado discussed the potential for creating custom solutions using TensorFlow, which, by the way, I think a lot of people are doing right now, and not many are being very successful, and deploying them to edge devices, weighing the knowledge gained against the cost of commercial solutions like Rockwell's. By the way, that there is a benefit to the knowledge you gain from attempting that yourself.
For sure.
But then Jordan comes in, and I think this was an incredible contribution, honestly. So Jordan provided insights into how our FactoryTalk Analytics Logix AI works, including symbolic regression process, which most people are unfamiliar with, okay? Mm-hmm. Which minimizes model complexity and is suitable for closed-loop control scenarios. So I do want to have a conversation about symbolic regression and kind of go into how that works, okay, and why Rockwell's solution benefits from that. And then we'll get into a larger AI discussion. A deployment of flexibility. Jordan elaborated on the deployment options for the AI models, including running on embedded hardware or virtualized containers, and the ability to retrieve training data sets for transparency and further customization. And then you shared a vision of the future of integrating learning and adaptation functions into PLCs to make AI an essential function, very important, akin to current programming functions. And just real quick, I want to define essential function. Essential function is something we must have and we take for granted. So, for example, in PLC language, an essential function would be PID control. You expect there to be some function for PID. Okay. So, all right, with that, Jordan, the first question I really have for you is, can you just give us a quick overview of Rockwell's current position in AI and machine learning, kind of, what is Rockwell doing in the AI space?
Yeah. I think I generally start this type of discussion with sort of an analogy that provides intuition on why we even care about AI, why we think we have any type of a legitimate entitlement to do anything meaningful with AI compared to NVIDIA and Microsoft and Google and so forth, and just why it's important, I think, to automation in the first place. And we kind of touched on this in our conversation about autonomy a moment ago, but I think really the most interesting applications of AI today are integrated with control systems, believe it or not, right? So if I think about a a self-driving car, like the full self-driving module within a Tesla. Granted, it's not perfect, but the progression of evolution that it's undergoing right now is really impressive, especially since version 12 that was released, I think, last August. And what that self-driving module is, the artificial intelligence that's embedded in it, is fundamentally a control system, right? And I'll give you kind of my definition of why I think that is. It starts with the ability to consume sensory inputs, not just from the vehicle itself, but from the environment that the vehicle is operating within. It has the ability to perform logic against those sensory inputs in order to translate them to optimal control outputs, right? So my steering angle, my rate of acceleration, or vice versa, the amount of pressure I'm putting on the brake pedal and so forth. There's some logical construct that translates sensory inputs from the environment in the vehicle to whatever outputs need to be taken in that moment, right? Now, the difference in that situation from a typical automation system is normally an automation system, that logic in the middle is going to be programmed. That means there's an engineer that is in the loop that understands sort of the first principles of the way that a vehicle operates in its environment, and they're encoding logic that comes out of their brains into a programming environment. And they are responsible for conceiving of all the different multivariable interactions that you can encounter in a driving scenario, right? So what you do when you're coming to a stop sign, what you do if somebody walks into the road, how do you stay within the lanes? How do you control your speed? And what you realize is that becomes a computationally intractable problem, especially for a human being to solve. And there's no way to solve an autonomous driving problem with explicit programming alone, right? So what it requires is this concept of machine learning, right? So rather than the logic being explicitly defined, the logic is learned out of large volumes of historical data, kind of in combination with learning in a simulation environment. And just in order to handle a dynamic, nonlinear, multivariable problem like autonomous driving, you need this concept of adaptable learning in addition to programming, right? So we all see the value that's created.
I want to clarify real quick for the audience, for anybody who gets lost. Yeah. So one of the important points of what Jordan's saying here is an engineer cannot possibly account for every single input and output. You can account for basically every output, but you can't account for every input. You can't account for every variable. A control theory you can never write a control theory, a human being, that contains every possible scenario. Like in the case of the autonomous vehicle, what we would do as an engineer is we would create logic that we would know that we have to do something when we see a stop sign. But what we wouldn't know is that we would need to also account for the fact that somebody ran the stop sign, or two people in a row ran the stop sign, and a car is going to need to react to that environment. That's something the car is going to have to learn. You have to create logic that can learn in itself to account for all the edge cases that we never account for. This is the fundamental difference between linear deterministic programming and non-deterministic programming, where the logic itself grows through a network of experiences.
Yeah.
But go ahead, Jordan.
Exactly. Sorry. Yeah. And I would also describe it as the fundamental difference between the definition of traditional automation and this emerging definition of autonomy, right? So, an automation system is programmed to operate in the absence of human intervention. A autonomous system learns to operate in the absence of human intervention, and ideally has the ability to adapt those learnings as environmental conditions change, right? So just, stemming from the Tesla example, like something really extraordinary happened with their version 12 of their full self-driving beta module that came out in August. And that is that prior to version 12, Tesla had about 300,000 lines of what you could consider to be programmable logic in their self-driving control system, right? And it was just there because they needed explicit instructions and rules to handle circumstances that they knew were problematic or just rules of engagement that they knew that they needed to abide by. What they did with version 12 is they threw all of that out, and instead they took about 20 million hours of historical driver video, where in the video they were able to keep track of the state of the vehicle in its environment and the state of the condition of the vehicle itself at a given point in time, and then also what the driver did in that moment in time, right? So they have a sensing input information and control output information all integrated into 20 million hours of driver video from actual Teslas operating on the road. And instead of that 300,000 lines of code, they trained a end-to-end neural network architecture that directly maps that vision sensory input to control outputs. And they were able to achieve like an inflection point in their level of performance that they had never before achieved with what turned out to be a much simpler architecture, right? And I think like this is where the relevance of this to Rockwell really comes into play. If you're Rockwell Automation and you provide a large percentage of the world's control systems for industrial manufacturing, and you see this type of innovation occurring in adjacent markets like consumer vehicles, and you realize that what this represents is a fundamental paradigm shift in the definition of a control system, you basically have to react, right? And I think that's widely understood at our organization now that the concept of control and programming is going to be disrupted by things like data and learning and adaptation. And if we don't adopt those types of capabilities into our products as like integral functions that just are thought of on an everyday basis as basic functionality in a controller, our competitors will do it, or some disruptive startup will do it, and we're not going to be able to grow according to the evolution of control systems. We'll lose market share. We're not going to be able to create customer value in the ways that customers need it in the future, and so forth, right? So I see this as like central, like an existential imperative for any company that operates in the automation space. And when you realize that this isn't just something for consumer vehicles, this is something that applies to manufacturing and industrial automation as well, where you also have multivariable, nonlinear, dynamic problems that you have to solve and solve very quickly and adapt your logic as environmental conditions change and so forth. We're going to see the adoption of those technologies just as we've seen them in vehicles.
So let me ask you this question. Then I'm actually going to divert from what my question was. But so I actually no longer have a Tesla. I just traded my Tesla in this last week. I had a Model 3 and then a Model S for a couple of years. Used full self-driving every single day. I used it before V12 came out. In a practical sense, the reason I sold it is I bought a ranch out in East Texas, and I can't. I need to drive a truck. I need to drive a pickup truck.
You don't have the power walls out there. Yeah.
So, but I'll say this: the practical consideration when V12 came out, the thing that fundamentally changed, three things. For a practical, number one, my Tesla started handling really wonky turns very well. So 5 road intersections or medians that weren't well marked that it struggled with before, it did an outstanding job with. Number 2, construction zones. So you would constantly have to intervene in construction prior to the release last year, and obviously because they trained on data of people driving through construction zones, that it handled construction zones just fine, including a really complicated one just down the street here. Mm-hmm. And number 3 was the need for me to start to intervene. I was generally having to intervene like once every 2 hours, like if I'm using full self-driving, and I got to a point where I was interviewing once a week, and I was using FSD every day to work from, to home. Every time I'm on the highway, I was just using it as my default FSD. So it did fundamentally change. But let me ask you this. Tesla owns the data. Well, actually, that's not true. When you buy a Tesla, you give them permission to use your data. You have to opt in. So I opted in, and I share my data, as did most Tesla drivers, because I think people who buy Teslas, their mindset's a little different, right? They're not freaking out about Big Brother and all that kind of stuff. I gave Tesla permission to use my data to train their models. isn't Rockwell going to run into a problem where aren't you going to need the customers to opt in
Yeah.
in order for you to really leverage? So, you've got all these automation systems out there. Aren't you going to need the clients? Like, you can get your partners to opt in, those who write like add-on instructions and stuff. But don't you need? Will the clients need to opt in to share their data in order for Rockwell to be able to develop these solutions?
Yeah, there's no way that we would or even could leverage that data without a explicit opt-in scenario that it's not only granted by the customer but is well understood by the customer, right? It's just not feasible.
They're basically a partner.
Yeah, absolutely. Yeah, and in order to get that opt-in, there needs to be a quid pro quo where you are creating value that is so compelling that customers are willing to engage in sort of non-traditional commercial motions like granting data access in order to get the value of that technology, right? So, and there's a lot of companies that have succeeded in doing this. So it's sort of like cloud-enabled companies that are providing like machine vision solutions for manufacturing and predictive maintenance solutions for manufacturing, where they have like something like a foundation model that is trained with a diverse set of customer data. And then that foundation model has like a child model that is fine-tuned to like the specific nuances of a given customer's machines or products. And you're leveraging the foundation model to have some like training basis and some performance basis to start with, but then you're fine-tuning it to your own specific purposes, and the way that you fine-tune it is proprietary. The only way to do that, I mean, you have to have like the utmost consideration about the anonymity of the data, right? So you can't let there's a lot of information within the data that you have to essentially reject and not pull into your cloud. You have to like generalize it in many ways, both in order to integrate it, but also to kind of protect privacy. And then there's also, you have to be flexible so that customers are going to be willing to opt in certain contexts, but opt out in other contexts. Like, for example, I might not be so concerned about the condition of the equipment that I buy from an OEM in terms of my like proprietary intellectual property, but I am very, very concerned about my recipes, like my specific recipes and the control parameters that I use to execute on those recipes. I might decide that that is so proprietary and so core to what I'm doing that I'm not willing to opt in on that. But I am willing to opt in on things related to, is this motor going to fail in this piece of physical equipment? Or do I have a crack or a hole or a tear in my product that I can pick up on with a machine vision solution? You have to have flexibility in the context in which you opt in, right? If given the willingness of some customers to opt in, it's a huge advantage that industrial automation environments are extremely data rich, right? So if you think about the average PLC probably generates about 100 gigabytes of data per year. We've kind of conservatively estimated that from our own.
Yeah, we use about 90. We use about 90 is our number. Yep.
Yeah. Not all of that data is useful. The most useful data is data that describes changes that are occurring in the process as opposed to steady state information. But if you then multiply that 100 gigabytes of data per PLC by, there's 3 million Rockwell PLCs in commission in the market. And then, you have Siemens and you have Beckhoff and you have all these other companies. You add all that data up. The industrial automation sphere is more data rich than any tech hyperscaler company. There's more data than YouTube, more data than what Meta has at their disposal. We actually ran some numbers. If you just look at Rockwell PLCs alone, if you were to take 1%, just 1% of the data that our PLCs generate on an annual basis, that is 60 times more data than what went into training ChatGPT 3.5, right? And the market doesn't seem to understand that. The market just doesn't seem to understand that machine sensor data is the largest and fastest growing subset of data on the planet. And PLCs are one of the predominant aggregators of machine sensor data, if not the greatest aggregator. You could argue that historians are a greater aggregator and that there's other things out there, but PLCs are the the system that consumes sensory input, applies logic, and produces outputs. And just by virtue of their function,
it is your business. We say this over and over again. The edge is your business. And I was speaking in Denver last year, and there was a guy, an automation engineer, who he made a great comment. And I told him I was going to steal it. He said, most members of industry, specifically manufacturers, do not understand the wealth of value that exists inside of the hardware that they've spent all this money on. They have the smartest assets in their business talking all day long, 24 hours a day, 7 days a week, and no one's listening. And those assets he's talking about are the PLCs. And the reality is that I preach this over and over and over again. The single most valuable asset in any organization is the rising edge and falling edge of every single event that happens in your business all day long. The singular most important asset in any organization is the data that they're generating all day, every single day. Well, let me. I'm going to use an example here. You were talking about the recipes and how we did an ML application. We were hired maybe 3 years ago to do an ML application for a sugar water manufacturer, one of the big two, right? And so, and anybody who works with the two big soft drink manufacturers will know, or the soft drink providers, is that their most important asset is the recipe that goes into,
for sure,
and nobody knows it. It's like the most protected, the most protected recipe in history, even more than Kentucky Fried Chicken. And what they wanted us to do was in the batch mixer. So they actually mixed the syrup with the carbonated water before this is prior to the bottling line. What they wanted to do is they wanted to stop wasting batches. So what they wanted to do was use machine learning to predict whether a batch was on the road to having to be wasted and automate the process of adjusting the recipe set points in order to save the batch. And what you had was very unique, non-proprietary, unimportant process control variables right alongside the most valuable asset that they had in their business. And one of the very first things that we had to do was we had to select the data points we were comfortable putting in a warehouse in order for us to train off of in the cloud. And we had to isolate that from the very important data points that they don't want getting out to anyone, and they've protected for 140 years, and no one's figured it out yet, even using mass spectrometers. So this is a very, very real concern for industry, is how do I protect the stuff I don't want to share, but share the stuff that I could really benefit from by training it alongside the data that other manufacturers are sharing as well. How is Rockwell leading that? How is Rockwell? I mean, I would argue Rockwell is uniquely. I'm very hard on Rockwell. I'm sure you know, like if you've looked at my background, I'm definitely. I love Rockwell PLCs. I give Rockwell a hard time on their lack of leadership. I say, Rockwell could be doing so much more good in the industry, and they don't. They're kind of still focused on, building, that monolithic model. And I know that that's not an absolute statement. There's a lot of good stuff Rockwell's doing.
Oh, you have a high, a strong criteria for what industrial automation majors should be doing, because you have a high degree of expertise, not just on the legacy automation topic, but also on nascent emerging topics like digital transformation and so forth. And you should maintain that high bar. And this type of feedback is important to us, right? So that's why it's important for us to be having this type of a conversation.
How is Rockwell leading right now? Obviously, by the way, the conversation I'm having with you, I haven't had with a lot of Rockwell execs. I've had a couple, but I would say just by virtue of you being a VP in this group is an indication that Rockwell has pivoted, has pivoted strategically, right? So how is Rockwell leading, from your perspective? Because what we really need are the leaders in automation telling manufacturers what they should be doing, right? Hey, here are the steps, and here's how it should work. how is Rockwell leading in that capacity?
Yeah, I mean, so in that scenario where you have like a beverage manufacturer with like an incredible proprietary recipe,
Right.
and like obviously in that scenario, the idea of just leveraging their data to build a cola manufacturing foundation model that other cola companies can download off the internet,
Right.
that's an obscenely ridiculous notion, and that's not going to work, right? And the way that we would handle that type of scenario is either in a services context, like the way that you did it in your experience, or just by selling like control systems and products that are natively integrated with ML functions. We would allow that company to train a model that predicted some sort of critical batch quality parameter, whether it's viscosity or the amount of sugar or some sort of product quality parameter. Upon that prediction, they can leverage some sort of an optimization toolkit to determine what the optimal set point manipulations should be in real time in order to maximize the likelihood that that quality is high over the course of the batch. And that model would be almost entirely trained with their data, run in their tenant, and not exposed to any publicly available training corpus, right? When I say it's almost only their data, there may be certain elements of like what happens in a mixer, like just like the basic first principles or physics of how viscosity reacts to different manipulations in power and temperature and things like that are just widely known and available just in the physics or chemistry community that we could bring into the model to speed up the process. But those would only be elements that are just publicly available and known, and the rest of it would be their own fine tuning from their available data sets. And in that scenario, you have to honor the obvious the obvious imperative that company has to protect their recipe, and you have to do it in a unique way, right? There's also going to be use cases where there's companies out there that fundamentally just want to make product. Like I just want to make, I want to increase my throughput. I want to increase my quality. I want to enhance my asset availability and utilization. And maybe I'm not the industry leader in my space, and I'm just trying to catch up and I want to scale production. So look, if you're going to use my data, if you're going to access information about the condition of my equipment and the quality of my product and the robustness of my process, I'm okay with that as long as I get a quid pro quo value proposition by leveraging ML, and I can access a model that's been trained with data from other companies that are just like me in the same position that I'm in. And we're all willing to contribute to this sort of open source data project and get models that help us do our jobs more effectively. There's a large community of people that are just like that, right? Not everybody's like the two major, beverage manufacturers where, proprietary recipes are really what they're trying to solve for, right? So you really need flexibility to accommodate both of those scenarios.
So let me throw this one out to you. Here's a ML application that we're currently doing right now.
Okay.
I was actually going to have Justin, our data scientist, on this call, but he's actually working with a client. But we're doing an ML, we're doing a bunch of ML applications, but nearly what I find is that most ML applications are use case based, right?
Yeah.
They are, I've got a specific problem and we believe ML is the solution. Here's an example. We're working with a, they're in heavy industry. This is in their where they're loading trucks. They have a truck loadout station.
Mm-hmm.
And they have automation systems that control how much material gets loaded into a truck at any given time. And then there's a horn that goes off and tells the driver to pull forward. And then the automation system loads another, 2 tons, and then pull forward 5 feet. And one of the problems they were running into was that the control systems always assumed that the driver was doing his job correctly.
Yeah.
He was positioning the truck in the right place.
Mm-hmm.
And they didn't want to have to go back to scratch and start over with the automation and account for these variables they didn't account for. So what they did was they said, we want to use vision to identify what type of truck pulled up. So there's only 6 or 7 types of trucks. We just had to train on that. We want a vision system to tell us that the truck is in the correct position at each phase of the loadout. Mm-hmm. And we want the truck to tell us when we want vision to tell us when we've had a spill. Okay. So that's a use case based. That's a customer basically listing, here we would need to solve these 3 specific problems, use magic machine learning to make it happen. Right.
Yeah.
Let's say I come to Rockwell. Let's say in this case, the control systems are Rockwell based. Mm-hmm. Tell me how let's say I wanted to partner with Rockwell on that solution today, because by the way, that solution could be used in every loadout application on the planet. Okay. Whether you're loading trucks or whether you're loading rail cars. I mean, that application could be used over and over and over and over and over again. I come to Rockwell and I say to Rockwell, hey, what do you have to offer so that we could do this within the Rockwell ecosystem? Because guess what? They're running ControlLogix out there right now.
Yeah.
They're running ControlLogix out there right now. How can we use the Rockwell ecosystem to achieve the same thing that we're achieving using third-party cameras and our own, open source models that we're borrowing from the interwebs?
Yeah, that's a great question. So I think the first way that I would answer that is, you kind of decompose the problem into the different machine learning disciplines that are required, right? So one of the things that you mentioned is you need to be able to classify the type and maybe size of the truck that's being loaded, and also detect and orient around the position of the truck, right? Is it in the right position? Are there subtle variations to the position that need to be taken into account, and so forth, right? So you have a machine vision problem there, right? You have a truck type and size classification problem, and like an orientation problem that you would have to leverage machine vision solutions for, right? So we have a machine vision offering that we're just now releasing, but I'll pause on that for a second. The other is kind of the control scenario that you're executing in concert with the sensory input that you're getting from the machine vision system, right? So if I have this type of truck with these geometric dimensions and this size that is oriented in 3-dimensional space in this particular way, what can I ascertain about that in terms of my material handling and loading of a material into that truck? Like, is the material going to stack up differently because that truck is at a subtly different angle than it is normally? And what can I predict about just sort of the dynamics of loading that type of truck that is in that type of position at this moment in time? Now you have a control problem to solve in concert with the machine vision systems, right? So your control problem is, I want to be able to predict sort of the future state of the material loaded into the truck and the way that that material is going to aggregate over time, right, as it's loaded. And I want to know if I'm going to encounter some situation where I, can no longer load it because it's all stacked maybe in one corner and it's not evenly distributed, or if there's a manipulation that I need to make to my speed or the rate of loading. There's any number of different sort of control or process control parameters that you may need to determine at the control layer using input from the machine vision solution, right? And you could go further with this. There's a lot of different ways you could address this, both by using historical data that describes how loading, the relative performance of your loading procedure according to different trucks that are in different positions. The other way that you could address that is with a simulation, right? So you could have a 3D physics-based simulation of the loading procedure. And in that simulation, you could actually introduce variation in the size and position of the truck, and then experiment with a reinforcement learning process about how you should change the material handling solution according to differences in the truck. Those are all ways that you could address the problem. Now there's the question of why would I do this with a commercially available off-the-shelf offering?
Right. How do I decide?
Yeah.
How do I decide? Exactly. Because I think this customer has spent, let's say, I don't quote me. I'm just pulling because I was trying to look up the number, but I think their total all-in spend on this solution, and it's done and it works and they're delighted and they gave us a 5, is maybe $30,000 total. So they were using existing we had cameras already there. We're using those cameras. We had 3 specific problems they want us to solve. We have a data scientist on staff. We're like, hey, buddy, here's their unified namespace. Here's the data that's available. Here's the cameras that are available. Work your magic. You know what I mean? And he's spinning up Conda and he's doing his thing. I think the question the community has, the audience really has, and I think you're uniquely positioned to answer it, is where does the line end where you do it that way and it costs, $30K and it's all by itself. You're not going to use it anywhere else. It's not going to be part of a much larger model that you're using across your enterprise. And hey, I need to use something a little harder, something a little more commercial, something a little more integrated into a much larger ecosystem. Where is that line in your estimation?
Here's how I would answer that. If you have, either through a system integrator partner or internally in your organization, the skill set to access the data, feature transform it, train a model, evaluate the model, deploy it and manage it in a edge compute surface, and that model satisfies the objectives of your use case, you should do it that way, right? However, there's a few nuances there. One, not everybody in the industrial automation space has those skill sets.
Very few, by the way.
And then maybe even a greater problem, the cost of integrating all that technology into all the different, the various sources of data and the systems that, play a role in the overall use case can be very high. And I'll give kind of an example of this. Like if you just think about machine vision solutions, the reason we even got into that space is because if I build a machine vision solution from scratch, I got to get the cameras, I got to get the lighting, I have to get mounting systems set up. Usually I need shrouds that protect the camera from dust and any like particulate disturbances that can occur. I then need, a pipeline to get my data into the cloud where I have GPUs. I need to train the model. I need to, register that model in like an ML ops platform for management. Then I have to deploy it to an edge compute surface. That edge compute surface is going to run inference against the, inputs coming from the camera. I need to evaluate what that inference is saying, like good or bad, yes or no, whatever, and then take action. And I might have to take action by creating a ticket in a QMS system or sending a message to a PLC to slow down a parameter or adjust something. So I have all these points of integration. And if those points of integration, if you do sort of like an honest assessment of what it's going to take in terms of time, materials, labor, cost to fulfill all those points of integration, that may be a very expensive solution relative to using a solution that's sort of pre-designed with that end in mind, right? So if you have a solution that's pre-designed to integrate your machine vision solution directly with your PLC so that you don't have to do that, and it's very easy to integrate it maybe to an MES system where you're registering quality information, and a lot of those points of integration are worked out for you, that can be valuable in certain situations. Now, the middle ground between these is really important, right? What you really want is you want to leverage the benefits of a configurable off-the-shelf solution, but insist to your vendor that they're using all of the innovation that's coming out of the open source community, and that product is going to grow in concert with that innovation, right? So, for example, like if your automation company is telling you that they're reinventing, TensorFlow or the attention mechanisms in a transformer, or they're building their own neural network architecture that's different than what Yann LeCun did. Right. I think that's kind of a red flag, right? So a green flag would be this space is moving rapidly. We're going to adopt all this capability that comes out of the open source community. And as that capability grows, so will our product. It's going to continue to use, these APIs and these analytical methodologies. But we're going to do a bunch of work for you to smooth out the integration edges so that it's very easy to implement. And then we're also going to guarantee its performance. We're going to have some sort of a support contract where we can keep the models up to date for you. We can guarantee that it's not going to break down and throw bugs and fail in various ways. So you get sort of the benefits of a commercial offering with the benefits of an open source core at its foundation. That's really what you want to look for, right? I think in general, that's the best of both worlds.
Yeah, and I would say, pose estimation is a really good example here. Like
Yeah.
I would be asking a commercial provider, what model are you using for pose estimation? And if they say it's something they've developed, I would really be like, that doesn't make a lot of sense to me, because tens of thousands of developers have worked on a series of models over the course of a decade that work really, really, really well. Why would you reinvent the wheel? That's what I would be thinking. I'd be like, well, if you're using pose estimation, I would want you to be drawing from that work that's already been done. However, I would like for you to make it easier for me to use the positions of each joint in a pose estimation for me to consume. I'd like you, maybe what you're providing me is the shim between what's in FOSS and my infrastructure, where I want to use the value of that solution.
Yeah, exactly. And there's probably work that we can do to enhance the reliability and consistency of the way that the solution works. We can, there's things that you can do to industrialize it, to make it easier to use for like the common control engineer.
Right.
You can implement logic and like application logic that enforces constraints that make it work in automation environments, as opposed to models that are used for Netflix recommendations that are very, very different, right? So there's a lot that the automation vendors can do, but they really should be using widely available open source systems at the core of their product, so that they're growing with the innovation sphere around AI, right? And I think that's our general proposition to our customers in the way that we see it. We even kind of enforce that standard when we're looking at acquisition targets or partnerships with other companies where we may leverage their technology in some respect. One of the first questions that we ask is, have you guys developed some sort of unique proprietary modeling methodology, or are you using widely available ML capabilities that everybody understands, right? And we generally don't engage in any type of commercial motion with the ones that insist on building their own lockdown modeling methodology that's patented and only they can use it, only they can understand it. It's a black box that you can never get into the inner workings of. It's just a problem waiting to happen.
But let me ask you this question. So in our case, well, we have developed, working with the client, we did a fully open, basically they already had an existing unified namespace running in an MQTT broker. So we basically had all the events. There was an existing data store, I think, from maybe 3 years of data, something like that. Maybe it was a little longer than that. And I know that that's what Justin was training the models on. Mm-hmm. He was using stuff off the shelf specifically to identify the trucks and stuff, and he was classifying the trucks. He himself was having to classify each of the individual truck types, but or the truck classes. But let's say we that solution's done, and we're like, this is really something you should be able to do in a suite. There should be a suite that exists that makes us be able to use this type of solution. And we're like, hey, the underlying architecture here is Rockwell. It's ControlLogix is handling all the automation. I know it's third-party cameras, right? All the sensors are like Rockwell partner sensors. So It's like, hey, why don't we take our solution to Rockwell and say to Rockwell, hey, Rockwell, how do we make this more widely available to Rockwell customers? Let's say someone wants to do that. What would the steps? A, is Rockwell even amenable to that type of thing with partners? And B, what does that look like? Because I believe we are not going to see the critical mass of adoption until we can somehow translate all the one-off things that are happening in the industry, like what we're doing, with a central point, a central repository, right? Whether that repository is a partner, or whether that repository is a GitHub, or whether that's SESME, that's kind of what SESME's mandate is. how would one engage that way? And it not necessarily answer the question for me, but more for the broader audience, because I'm sure we're not the only ones who have developed solutions like this where, hey, this should be more widely available, but we don't necessarily want to stand up a company that's going to take this to market. We need to go to someone who's already going to market and make it available.
Yeah, no, the easiest way to do that. So we have we have lots of agreements with like system integrators, for example, that will design something, you know, that typically uses our products to some respect that they believe is repeatable in a given industry segment. And what they're really looking for is a channel to market to begin to implement that for many more customers in that segment. And it's really as simple as, you know, the system integrator defines what the solution looks like, which Rockwell products it uses. For example, you know, if it uses ControlLogix or it uses, you know, Optics, which is our new HMI system, or whatever. And, you know, they build a solution that kind of comes into our marketplace that they can either co-sell with us or sell independently, but we provide, you know, some level of support in the sales process, right? And those types of arrangements differ depending on what you're really trying to do. But one of the things that we've decided recently is that, like, okay, if you look at companies like Intellic is your system integration arm, right? Am I saying that right?
Correct.
Look at Intellic, kind of like what Calypso grew to be over time. Some of the things that Rovasys is doing. There's a lot of like really impressive and advanced system integrators out there that are not only skilled with just traditional industrial automation domains, but also, you know, nascent emerging technologies like AI. What we're really trying to do is elevate our relationships with those SIs or even distributors in certain cases so that they can concoct these different solutions from their experience that maybe use our platform components and build a market for them, right? You know, construct them into offerings, leverage our market access channels to sell them to other customers, but still maintain ownership of them and, you know, be able to operate a viable business without having to, you know, set up their own entity and reinvent everything from scratch, right? You know, the terms of how we would do that depend on the different circumstances, but that's probably the way that we would go about it.
Here, I'll give you another example. I mean, this for the community. So here's another ML example. And one of the things we've struggled as an organization with is, you know, we know that we can leverage artificial intelligence, you know, so again, AI is computers mimicking human intelligence. Machine learning is computers learning from data. Okay, so ML is a subset of AI for those of you who are listening. So if you hear me using ML and AI interchangeably, it's kind of because they are in certain applications. Here's another example. We have a food and beverage client who makes you know, they basically have a machine that outputs trays full of dough. Okay, and I think the maximum number of, you know, I think it's 24 slots for the dough that can be in it. If you're building a brand new production line, right, and we want to be able to monitor how many balls of dough are in the tray. Is it 24 for 24? Is it 23 for 24? Is it 20? And which slot in the tray is empty because there would have been some waste thrown out? If that's a brand new production line, that's an easy one. Hey, I'm going to go get a vision camera. I'm going to point it straight down as it comes out. We're going to take a quick shot, and then, you know. But that isn't how most manufacturers are. Most have 30-year-old, 40-year-old operations, and they're like, you know what? We need to be able to count the balls of dough coming out of this machine. And so what they asked us to do was, can you use vision? Can you use what we currently have and do it as cheap as possible and count the balls of dough coming out? Because we need that for our yield calculation for OEE. Now, the underlying control architecture is all Rockwell. It's all ControlLogix. And what we really wanted to do was we wanted to get that back into the PLC. So what we did was we use an existing camera, train a model, we count the balls of dough, and then we basically give an XY coordinate. We say at this X, this Y is empty. This X, this Y is empty. And then what we do is we publish it into an MQTT broker. We use HiByte to read that, and then we write it via OPC, you know, into the ControlLogix PLC.
Yeah.
But let's say I go, what we struggle with is this. Okay, we've developed this now. And honestly, Rockwell should know about this. Or let's say it's Siemens, or let's say we need to go back to the OEM and we need to say, we got to make this easier to do. Like we need to make this more native. What is Rockwell? How should people who are using Rockwell technology communicate these needs or these new solutions to Rockwell? And B, is Rockwell currently what is Rockwell currently doing now to make that easier? Because I know you're not sitting on your hands. You guys are doing lots of stuff. You guys have come up with a ton of new products that most people don't know anything about yet, right? Can you answer those two questions? A, how should we take that to Rockwell? And B, what is Rockwell currently doing to make that type of stuff easier?
Yeah,
we're doing all that with off the shelf stuff.
You would bring that to Rockwell's attention probably if you're operating as an integrator, you would probably bring that to Rockwell's attention through our partner network, right? So we have people that manage relationships with local SIs, global SIs, and so forth, and you would broker a conversation to say, hey, can we collaborate on this solution so that we can scale it together? We built this interesting thing. We want to scale it in the industry. We want to, leverage Rockwell support in doing so. And you should have a pretty easy avenue through our partner network to be able to do that. In terms of making it easier, I'll give you like some examples of the way that we would approach something like that to make it easier. For one thing, like I might want to be able to, when I'm in the actual design phase of my PLC programming, I'm envisioning what my control system is going to do, the logic that it's going to carry out, and so forth. I might want to be able to design with the anticipation that I'm going to have a machine vision system that is monitoring balls of dough that go into 24 different slots on a tray. And I want to be able to write logic that's very simple, like if I see a tray that doesn't have a ball of dough in it, take this action. I want to be able to do that natively in Studio 5000, right? Why should I have to figure out the logic of what I do externally when really the experience of programming automation occurs in these IDEs? I want to be able to express my logic and rules and concerns directly in my programming environment, right? So that's one of the ways that this is kind of like one of the benefits of having an off-the-shelf solution that also uses open source frameworks, is that your application context can be more intuitive. I open up Studio 5000, I'm programming, I can write a few lines of logic that just say, when I see a ball of dough missing from a tray, I'm going to take this action, right? That just makes it easier. It also makes it easier if you're going to go to the OEM that makes that dough deposit system, like whatever, like an extruder or whatever it is that's extruding into the tray. You could theoretically make it very easy for that OEM to integrate that solution directly into the machine so that every machine that they sell just has that capability with it, right? And if it's ingrained into the application context of the PLC code, it makes it easy for that OEM to adopt. So that's like one of the ways that we would think about making it easier, just like the in-context integration of all those systems so that the experience of the control engineer is much easier.
And let's take it home with this. I'm going to actually ask two questions. We're going to take it home with, hey, your recommendations to manufacturers today, you're doing nothing with ML whatsoever. What should you be doing? Well, I want you to take it home with that. But let me ask this question beforehand. Here's a very common in our community and even in Intellic, and I'm technically at 4.0 Solutions. I'm in the process of selling Intellic integration to the employees. And I'll be out of the integration business altogether. I'll still consult and be an architect, but I won't be doing it for an integrator. I'm a huge fan of I know we were talking about Rockwell, but I'm a huge fan of the Opto 22 Groove Epic control system. Now, the Opto 22 Groove Epic is, I would say it's similar to CompactLogix. It's not on the level of ControlLogix. There's a whole host of shit you can do in ControlLogix you can't possibly do with a Groove Epic. But one of the things I love about the Groove Epic is that it is an industrial PC. There is an isolated CPU with quad-core CPU for IPC applications, and then there's an isolated quad-core CPU for the control application. And one of the things, and the reason I like it so much is because what you just talked about, which what we should be able to do easily from our controls platform, is actually not easy to do. It's hard right now. That doesn't. It's hard to find a platform where I can do.
Yeah.
I can do that. I can do my inferencing at the same time that I'm handling process control, right? And so right now we're doing inferencing on an isolated core, and we're not messing with the control core. What is Rockwell currently doing?
Yeah.
How? Because I'm not fluent right now in the newest offerings on the AI side.
Yeah.
How do you do that with Rockwell?
Yeah, there's kind of two different ways. Well, I think at least two different ways, but like the two most common ways you would do that. One is we're introducing a dedicated edge compute surface to supplement the Logix controller that's essentially called Logix Edge, or I think it's called today it's called, like, you can find it on our website as like the Logix Embedded Edge Compute module, but we just call it Logix Edge. And what that's intended to do is kind of similar to what you're describing with that other PLC vendor, where you have a dedicated compute system for inference, like ML inference, but you also have the benefits of like a premier integration with the compute surface that runs in the controller. And when I say premier integration, I mean like because we own the underlying details of the PLC and we can kind of get into the engineering weeds, we can do things like CPU interrupts that make like inference much faster, and that can like deprioritize certain processes in order to prioritize your inference process, especially if it's like safety critical and things like that. And it's a lot, you get a lot more performance out of that scenario than just plugging in a edge compute device via OPC UA and brokering the communication that way. So that's one way, which is like the Logix Edge device. The other thing I'll mention there is like that thing is designed with openness in mind. It means it has MQTT connectivity, OPC UA connectivity, REST API connectivity. It's designed such that you're deciding what you put on that and what it integrates with, and it's not designed in a situation where it only integrates with Rockwell hardware and software, right? So that's an important point. You cannot win in the AI space unless you adopt those standards, in my opinion. The other way is we have a platform called Optix, which is really becoming our general purpose edge and HMI system. So it's not meant to only integrate with Logix PLCs. It's really there to be a general purpose edge system. So Optix provides the HMI design environment, the HMI runtime, and then any of the supporting IPC or edge compute functions that you need to deploy a model to the edge. And if what you're doing is different than just interoperating with a PLC, but there's like other systems involved and you really just need a general purpose edge environment, Optix is the way that we're going to market with that. And again, MQTT support, OPC UA, you can just publish your own models or content to it, virtualization or containerization, so that you can, leverage that. Those are like one of those two ways would probably be sufficient. If you really want deeply ingrained interoperability with the PLC, especially in like really like fast moving environments where like speed and precision is key, like food and beverage or consumer packaged goods, Logix Edge is probably the way to go in that scenario.
Because you're going to get, I want to make sure I stress the importance of that compute running off the backplane. You're connected to the back. I mean, Rockwell writes the kernel that's running. So, you're getting kernel level speed. You're getting board level speed. Right. You're not running through two abstraction layers, at least at the OS. Most are coming through the OS down into the kernel, down onto the board. And then those who are running in Java are literally running in a JVM into the OS, and into the kernel, back onto the board. A lot of people don't understand why some things are faster than, computer scientists always do. But like the average OT professional has no idea why this one thing is faster than this other and why it's even a consideration.
Yeah. And if you're making diapers, right, and you're churning out, millions of diapers in a given cycle, the nuances of what happens in a low level millisecond period is incredibly important. Like you can't ascertain quality or make quality inferences at all unless you're getting into extremely low latency situations. And that's where that direct kernel level or machine cycle level integration with the controller is really important, right? That's really, I think, the way that we think about the advantages of our edge strategy. Not all applications require that level of performance, obviously. And there's, using third-party applications or even open source applications for edge and container management is totally fine in a lot of areas, but where you need that level of precision and speed, it becomes really important.
Yeah, I would argue start open source, and if it doesn't work, then move. Make the move. Yeah, by the way, you have something to take to the OEM. You have something to take to the vendor and go, this is what we tried that didn't work, and it would work if it would just be faster, or enter in whatever failure point was. And now you're going to the platform vendor and you're saying, hey, can you make this work the way it's designed? Because it's just like wireframing. I say it all the time. I use FOSS for wireframing solutions. That's what I do. I decide how much I'm going to spend on the commercial offering based on the criticality of what I've built, and its efficacy. And don't be afraid to use them both. And you clearly stated it here, and in pre-production we talked about it. It's not either or. It's both, depending on certain. Depending on certain criteria, and this is where the solutions architect comes in. With that, by the way, I've been deep diving on optics, but I've not really done a deep dive in the edge compute module. So I do appreciate. I've been doing a big deep dive on optics, and I'm going to do a whole host of videos on it. So, but let's talk about manufacturers, and we'll take it home. Mm-hmm. Every single manufacturer or anyone in industry who's getting involved in learning from their data and then take action on their data automatically using AI and ML, every single one of them has to do it for the very first time. Because this hasn't existed. We don't have a generation of people who've already been doing it. So what is your recommendation to the manufacturer out there, or the member of industry out there who's saying, I've got data, some of it I'm listening to, most of it I'm not. I really want to benefit from it. I want to do it as smart as possible. I don't want to waste a lot of money in my first couple of iterations. What's your recommendation where they should be starting? I mean, they hear it from me all the time, where I think they should start, but I think they'd benefit from hearing from you. What would the first couple of steps be?
What now? Are you asking about use cases, or just sort of general philosophies for getting started?
I think honestly, the general philosophies are probably going to be most valuable.
Yeah. So what I would say, there's kind of a difference in the way to go about it when you are validating the economic relevance of machine learning against your data for the very first time, versus saying, okay, that relevance is well understood. Now we need to scale, and we need to go at it in the right way, right? And generally what I do when you're just first exploring the value of machine learning for advanced process control, for machine vision, predictive maintenance, planning and scheduling, whatever the use case is I tend to say pick some production function that is mission critical to your operation, where you either have a quality or throughput or asset availability constraint. Take the data that you have available and run kind of like a full closed loop experiment that demonstrates the before and after value or performance that you get with a machine learning capability. And I say that just to ensure that the technical feasibility and the economic value is truly there to sort of justify the effort. And you should be able to do those experiments with open source technology that's free, off the shelf, very easily. Oftentimes even in low code application environments that there's a lot of those that exist today, and just demonstrate that, hey, if I have a model that's manipulating this control logic in real time, I'm getting more robust control. Or if I have a machine vision solution that's detecting these anomalies or defects, I'm going to improve my yield, and do that in a very, very short term and focused experiment, like in one area of production. That's going to yield some decision of whether it makes sense to really go all in on this and invest in it in a large scale, when you've made that decision, now it becomes, it's a difference between, am I doing this in the first place, and how do I do it right? And this is where you really need a cohesive platform for data management, contextualization. This is where you get into topics like the unified namespace and having omnipresent connectivity and data integration mechanisms that are everywhere. This is where you're going to get involved in edge to cloud integration, IT OT convergence, and it's really going to start your digital transformation journey. That digital transformation journey, though, is justified at the front end by some early experimentation and innovation that proves this is feasible and it's economically viable, right? That's generally how I look at it.
Yeah, I say all the time, we're always saying, give us the problem you've been trying to solve. I ask them all the time. Right. Give me the problem you've been trying to solve for a week, a month, a decade that you haven't found the solution for yet. And let's see if we can use technology to solve it for you. And let's also do it in a really short period of time. Like, we bite off a little tiny bit and we're doing feasibility here. We're doing proof of value. We're doing a proof of the concept. That's it. 12 weeks, spend a tiny amount of money. Don't buy any licensing. Don't do anything. Let's just dip our toe in and see what the art of the possible is. And from the art of the possible, we can decide what we should invest in. Right. And it's good to hear that that's your philosophy as well. I
heard that philosophy because I worked for a system integrator for a long time. And when you actually experience the reality of this stuff, right. You spend 6 months in a tire plant, you learn things like that. You realize you really can't, you want to start with that early experimentation and, prove the feasibility and value before you embark on a large scale digital transformation initiative. So.
I worked with a client maybe a decade ago, and the CEO used to say, ready, fire, aim. He got it from the book, Ready, Fire, Aim. But he used to say, our philosophy is ready, fire, aim, make mistakes, recover quickly. And he, when we were originally engaging with him, he said, that's the approach. We're not going to overplan anything.
Yeah.
We're going to get to work and plan on the go. And we're going to learn from our mistakes and we're going to adjust. And I remember thinking, wow, that is how we should be doing this. That's how all integrators should be operating in new ground. Now, I'm not, when it's a tried and true operation, overplan, right? P&IDs up front, the whole deal. But when we're breaking new ground, like with ML and AI, I really think that that's the approach. The approach is we need to test the art of the possible and then decide what to scale.
Yeah, for sure.
And that's where we are right now, I would say.
Yeah.
So, Jordan, man, I really appreciate you coming on. I'd love to have you on again and bring Justin in and a couple of the other data scientists that I'm really close with. And
that'd be great.
Really nerd it out, man. I mean,
I'd love to. Yeah, thank you so much for having me. It's my pleasure, and I appreciate you spending your time to talk to me. And looking forward to the next one.
No, it was invaluable. And people want to get a hold of you. Is your LinkedIn the best place to get a hold of you? All right, we'll make sure we include a link to your LinkedIn in the description of the video down below. Thank you guys for
Sounds
watching.
Good.
Like, subscribe, comment down below, and we will see you in the next one.
Thanks so much.